Welcome students. In this video, I'll be talking about understanding linear combinations of vectors. I will also be showing you how to determine if a third vector lies on the plane of B1 and B of another two on the plane of another two vectors by solving the system of equations. So please subscribe. So a linear combination of vectors involves expressing a vector as a sum of scalar multiples of other vectors. This concept is foundational in linear algebra and can be used to determine if a vector lies within the span of other vectors. So how to convert two vectors into a linear combination? So let's say you're given vectors b1 and b2 in a vector space. A linear combination of this vector can be expressed as b equals a times b1 times plus b times b2. So let's say you're given vectors b1 and b2, then a linear combination is b equals a times b1 plus b times b2, where a and b are scalars, and b1 and b2 are vectors. So a and b are scalars. This combination spans a plane if the vectors are not collinear. So collinear means implies that vectors not collinear implies that vectors are not on the same line or are parallel lines. So to determine if another vector, say b3, lies on the plane formed by b1 and b2, you need to check if there exist scalars a and b such that, so if we determine, so let's say you want to check if a third vector lies on the plane of b1 and b2, then what you need to do is you need to check for existence of a b such that b3 is equal to a times b1 plus b times b2. So let me give you one example. So let's say you have vectors b1. Let's say you have vectors b1, 1, 2, 3. So b1 is equal to 1, 2, or 3, and b2 is equal to 4, 5, 6, and b3 is equal to 5, 7, and 9. So then a linear combination of b1 and b2 is b equals to a times 1 2, 3 plus b 4, 5, 6. So that would be the linear combination. And let's say we want to find out if vector 3 is in this plane, b3 on plane. So we need to find a and b such that 5, 7, 9 is equal to a 1, 2, 3 plus b 4, 5, 6. So we need to find a and b. So how do we do it? We're going to set up a system of linear equations such as the following. So we're going to have system of linear equations. We're going to have a plus 4b equal to 5, and 2a plus 5b equal to 7, and 3a plus 6b equal to 9. And now we're going to solve this system. We can solve this system using the substitution method. So using substitution, find a and b. So on the right side we can see that we can solve for a on the first one, and we can get a equals to 5 minus 4b, and then we substitute that on the second equation, which is 2a plus 5b equals 7, and then we substitute it for a, then we solve for b, and we find out that b is equal to 1. Now we plug it in back to a here, and then we get that a is equal to 5 minus 4 times 1, which is equal to 1. So a is equal to 1. So the solution to the system of equation is a equals to 1 and b equals to 1. This confirms that vector b3, which is this one, vector b3, this one, is indeed a linear combination of b1 and b2 and lies on the same plane they span. Thus b3 is indeed a linear combination of b1 and b2 lying on the same plane. And we can check it as follows. Because 1 times 1, 2, 3 plus 1, so we plug in a and b, plus 4, 5, and 6 is equal to 1, 2, 3 plus 4, 5, 6, and now we add them corresponding ones, and we get 1, 4 is equal to 5, 2 and 5 is equal to 7, and 3 and 6 is equal to 9. and this is equal to B3. So indeed we check that vector B3 is in the span of this is a linear combination of B1 and B2 and lies on the same plane as B1 and B2. Thank you for watching. Please subscribe. See you soon.